All right, can everybody see this?
Yes.
Awesome. So my name is Carleton. I'm going to be talking about migrating Heroku from Heroku to AWS using Docker. This is a problem kind of encountered recently with the company that I am running at the moment. So a little bit about me. I am a programmer, VR game developer, and recently an author. I've been doing this for a while, various different platforms, Ruby for the last 5 or 6 years, and previously before this, .NET. That didn't work. So right now I'm the CTO at Algoly. And what is Algoly? And this is pertinent to the talk because it's kind of why we had to move. We had to do this move, but we deal with a lot of data, large streams of data, goes through this, what I call the Algoly magic, and it provides these usable components to companies, API, microsites, WordPress plugins. And this center part was sort of split between AWS and Heroku. We had Rails apps running on Heroku and literally everything else running on AWS. And the core logic that we had was running on Heroku. And at the time when we began, this was really helpful. We were able to iterate. And this kind of goes into the pros of Heroku. Easy to get started, free to start, easy to manage, add-on marketplace. Essentially, you can get up and running very, very quickly. And it's probably one of the best tools I think has come out for me, and not having to tap into my IT background and always have to be the guy to set up the servers and manage them. Now Heroku just does it for me. But it's sort of a double-edged sword because it's expensive to scale, and there's also hard memory limits. As you get towards the upward limit of Heroku, you start paying $250, $500 per dyno. So you could easily incur an exorbitant amount of expense through using Heroku. And this was what's happening at Algoly. We were having to split off a lot of our work into multiple processes and distribute it. And it was just becoming, we needed more memory for certain processes. And it was very difficult for us to get an effective scaling platform that was not expensive. So, I'm paying too much for my IT infrastructure. What do I do? AWS EC2 is cheap and easy way to run virtual servers. It's one of the core foundations. It's been around in AWS since pretty much it launched. And let me know if I'm going too fast. I haven't done a talk in a very long time, so I might be going too fast. So if there's any questions, then just stop me and let me know. But so with AWS, the issue becomes, well, how do I configure these servers? I'm using Ubuntu or Red Hat or CentOS, and there's a whole bunch of configuration that goes into a Rails app, right? You have Postgres, Sidekick, Rails, maybe even more. And this is where using a tool like Docker provides an easy way for us to do configuration management using containers. And I put this picture on the bottom right-hand side because I felt when I was learning about Docker, this was the best example of, what is a container? Well, the shipping industry had to figure out a way to standardize moving anything from anywhere in the world to another part of the world. Things are big, small, soft, hard, heavy, light, but it doesn't matter if you have one of these containers that are a standard size and, you load up, you are responsible for loading up that container with whatever you want to ship, or the company that is shipping your stuff wants to ship. And the company itself that takes the stuff and ships it somewhere else just takes this container and goes somewhere with it. So Docker does that for us for our Rails configure, for our server configuration. We can tell it, I have Postgres and I have Rails, I have Sidekick. And I do see some people posting on chat. If there is a question, just let me know because I can't see the chat while I'm in the presentation mode. So we can put all this stuff into Docker and allow and easily host this on EC2. So there's a few elements that make up how to configure Docker. There, in our Rails project, we have a Docker folder which has all our configuration. This allows Docker itself to live sort of side by side with our Rails app, and it can be checked into version control. And then when you take it out, when you clone the repo, you could choose to either run the Rails app in whatever environment you want, RBM, RVM, or you can use Docker. There's also the Docker compose file, which is a way to describe multi-container environments. You can use Docker by itself, but for the most part, you're going to need more than one container for most applications. So Docker and Compose will unify all these different configuration files. And then finally, there's environment variables, environment files. You often need to set environment variables in Rails, many different things. Your MailChimp keys, your other API keys, whatever. So I created this Rails example app. You can go here, you can clone it. It has a very, very simple Rails app that has all of the files that we're going to be going through and looking at and describing. It's all there. You can literally take this out. You can build it with Docker, and it will work. So the first step with Docker is we have to create a Docker folder. In your Rails app folder, you create a Docker folder, and inside that, I am hosting a simple Rails app. So I need an app directory and I need a web directory. The app directory is going to hold my Rails application, while the web directory is going to hold an Nginx configuration that is going to handle requests for Rails and forward them to it. So inside of each of the Docker specific container folders, we have a Docker specific file. And I have seen, I'm just only recently beginning to use Docker and really fully understanding it. I have seen different casing for this Docker file. Some people say you don't have to capitalize the F and you're actually not supposed to. So forgive me if this is incorrect, it does work. But anyways, I have one app Docker file, that's for my Rails app, and I have the web Docker file, and that's for Nginx. And in the Rails root directory, we have the Docker compose file. And this Docker compose file is a YAML file, and again, we use it to describe where the app Docker file is and where the web Docker file is. In the Rails app folder, in the Docker web folder, we have to create the Nginx config file. This is specific to Nginx. It's used to configure this server, and you'll see that file later. So as you saw, we have two app container config files. These literally just describe the container that will run our Rails app. The app one will run our Rails app. And here is, let me move this because I can't see it. Here is the file that is in the repo that I posted. I'll go through this. I added comments to each one of these lines. From the top, we have this from. So each line in our Docker file constitutes or has a command that we're going to run, and then some sort of identifying attribute for that command. So the top we have from Ruby 2.7.1. So this is literally saying, give me a Docker image from the Docker Hub. And there's all sorts of images up there that you can pull from, not just Ruby, any environment you can think of. And this one is specific to Ruby. So this gives me an image for Ruby with Ruby 2.7.1, kind of gives me a base to start with. And then we have these run commands. These runs allow us to run specific commands. So you can see after the run command, we could see the actual command that's going to be running. I am adding to the Debian apt-get available repositories. I am installing Yarn. I'm sorry, making Yarn of the latest Yarn package available, and then going through and updating and installing all my necessary dependencies that I need for this server. A lot of times when you're running Rails locally, Brew would handle a lot of these on your Mac platform, where if you're going to install OpenSSL or something that might be missing to get one of the gems that you need installed. The other important command is the env. This is going to set environment variables specific to when we are setting up our environment. And down here, you can see some stuff that looks a little bit more familiar. We're installing Bundler. We're doing a bundle install. We're copying the project files, and we're doing a precompile. And finally, this is very important. The expose allows us to say, this container is going to expose this port to the outside world. When I was starting to work with Docker, one of the things I had the hardest time figuring out was, how do these containers talk to each other? And there's a few more things in Docker Compose that provide the ability to set this up. But specifically in this Docker container file, we are saying expose 3000. That's the default port for Puma. We're going to have Nginx talk to that port for Rails. And then finally, the command to start Rails using Puma. So obviously you can change this if you are using Unicorn or one of the other Rails servers that are available. Any questions? Okay. And this, I know this is a lot to take in, so the slides will be available, and plus you can play around with the GitHub repo. So the web Docker file, like I said, this is a container for running Nginx. Nginx is going to essentially handle requests over 80 for our server, or for Rails server, and forward it. Nginx is very quick. It allows us to provide a lot of configuration sort of before Rails, and allows us to do things like reverse proxying and all sorts of very interesting web-specific hosting. So this is the web Docker file. Again, you could see at the top we have this from. So the Nginx, we are getting the Nginx image from Docker Hub, and we are installing our dependencies, Apache. We are setting some environment variables, setting work directory, copying some files, and running some commands and exposing 80. And then finally we see we're actually running Nginx. So a lot of this, I didn't figure all this out on my own. Some of this was available various different places. People have example Docker files for different environments. Like like I said, maybe you don't want to use Nginx for some reason. You want to use some other sort of proxy for Rails. These sort of things exist out here. Then we have the Nginx config file. And this, I won't get into this too much because this is this could be a whole nother talk of how do you configure Nginx. It's got this whole configuration DSL, and for the most part, this is pretty standard. So I would say if you have any other questions, you could always hit me up or contact me, or I'm sure that you can find the documentation is pretty thorough. So I won't linger too long on this one. So finally, Docker Compose file, and this is Docker Compose itself is a very powerful tool. Allows us to do a lot of things on top of Docker. As the name suggests, it allows us to compose multi-container environments. So we could have a whole suite of servers running. We have Redis, Postgres, Sidekick worker running. These are all things that I had to do when migrating from AWS, because our Rails application that does the central processing had a lot of these items that were needed. So here's the Docker Compose file. At the top, we skip over version 3. I didn't actually look into what exactly the versioning is, if it's specific to Docker. But if we start with volumes, since we're running a Rails app, I decided to use Postgres, and we're going to create a disk volume to put that for where we need to put that data. And under here, under here we have the services portion, and this is going to define each of our container. You can see we have a DB container, an app container, a web container. So these are the 3 central containers that we need for a Rails application. If you notice, there's no Docker specific file for DB because, well, we don't really need to do anything special with the DB container. We simply need a Postgres database. I specify this image, Postgres 12. I say use the Postgres data volume that is specified up top. And I set this one environment variable for host auth method trust. And we're good to go. And we'll actually see this spin up, but there's no Docker file specific configuration we need to do. The app, you could see here, we specify where our environment file is, which is under doc app environment, app-env. And these, what we were talking about before, how the different Docker systems talk to each other, the depends on is very key to that. So we have an app, a Rails app, and it depends on the DB. It doesn't depend on the web, because the web forwards requests to us. But the Rails app depends on the DB. So in order to tell Docker that we need these two, we need the container needs to be able to talk to DB, we need to say it depends on DB, and it opens up the necessary ports required for that communication. I don't know why it keeps clicking on it. Sorry about that. So under the app, we also have the Docker file, and this is how we build our container. And you can see in the Docker folder under the app directory, we have app Docker file. And finally, we are exposing ports 3000 to the world, well, to our Docker container environment. Finally, the web container, which you can see also has the web Docker file where we find that. It depends on app because it is sending requests to our Rails app. So it depends on the app directory or app container to be available. And we are exposing 80. If you enable SSL, you would obviously need to add ports 443 underneath here, or else the outside world would not be able to get to this Nginx file. So there is a few things we have to do to Rails. One of the main things is we need to tell Rails where DB, the Postgres DB is. If not, Rails won't know where to look. And it's pretty simple. One thing to pay attention to is the host says DB here. And that, if you look, and I'm going to go back, correlates to the container name DB. So this will actually become the host. This tells Rails to go look for the database that is the host DB, that the container we're running. And other things in here, I didn't set a password for this Postgres database, and it's the default Postgres username. Not the best security measures, but it's an example. So finally, we have the environment variable file. And this is what I was mentioning before, where we have to essentially set up environment variables for our app. And if you've used env files before, it's pretty standard syntax. The environment variable equals what the value is. And in this app, I'm simply saying, well, I want to run this in production because we're going to host this on EC2. And I want to serve my static files. Rails want to serve the precompiled assets. In my personal app, in my company's app, we created a sample file that is checked into GitHub, because this can be filled with all sorts of sensitive API keys. I would not check all those into GitHub. Not the best idea. So have a sample file that then locally, if your developers can copy and set up, kind of like having an application.yaml in your config directory for Rails. Okay, finally, we build the Docker containers using Docker Compose. And this is pretty simple. Since we've set up all these files, we simply say Docker Compose build, and it goes through and it creates the image. Pulls the images and runs all the commands. So to start the Docker containers, it's another Docker Compose command. Very simple. Docker Compose up, and then D simply means detached. You can run it without that, but then you get sort of a similar result as running like Rails server, Rails S, where until you press Control C, it will keep it won't relinquish control back to the terminal. You can also check the status of the Docker containers. This is very helpful because unless you're running locally on your Mac, or we'll just say Mac, you can't really see what's going on. There's a nice dashboard that the Mac, when you install Docker, provides. So Docker PS or Docker Compose PS. Docker Compose PS gives us a little bit more icing on top of the regular Docker PS command. But as you can see, we can see the container ID that's running, the image it's running, the what's it called? The command that it started with, and all the ports that are open, and the names of the actual app. The container ID is important because if you want to run other commands, sometimes you will need the container ID to run them. So obviously we have to run, if we have a Rails app, we have to run Rails rake commands, db migrate, create. If you want to run scripts, Rails scripts, we need some way to do this. So Docker Compose to the rescue. It's pretty simple. We use the Docker Compose command to run, as you see here, in the app, and this correlates with our container name. And we run this command, rake db create. So I'm running db create, then db migrate, which I don't show here, but this will essentially run these commands on the container. Um, and then finally, once we do all this, the 3000 exposed, if we're running this locally, we can browse to local host 3001 and we can see our Rails app. So this is the Docker portion. We still need to create the AWS EC2 instance. So I've provided some screens that kind of walk us through this. You can set up a free EC or AWS account, and as long as you only use free tier status resources, it will be free. I think there's a limit to how long. It's like a year, but it allows you to really play around with a lot of things and get used to AWS, which is quite a large, complex environment. So here I went to the EC2 portion of AWS, and I'm saying I want to launch a new instance. And you can pick all sorts of volumes to run from. I am picking Amazon's AMI. It's usually one of the cheaper instances to run. And also there is performance benefits of running some of these servers. So I chose, like I said, free tier eligible, this micro. It's a pretty small server, 1 gig of memory, 1 CPU. It's running the elastic storage, and it's nothing special about it. It's pretty low end instance that we're going to start. So we review it, no changes needed. So I go ahead and I launch my EC2 instance. Now, the next part of this, which is pretty key for getting into the server, is creating a pair or choosing an existing key pair. And this is what we use for SSH to access the server. So I created a new pair here, Rails server key. You can see here, and I downloaded it, and it looks like it's a PEM file. And you place it in an area where you can reference, and I'll show you that when we SSH into the server. So I go ahead and download it, and I launch the instance, and the instance starts up. You can see here's my micro server running in the East 1A availability zone. It's running. I click connect, and I get some information on how to actually connect to the instance. Very important. Don't forget to change the the PEM key to be able to be executable. And we run this SSH, specifying that PEM key and specifying where our EC2 instance is. So there's a few things that you need to do in order to allow your new EC2 server to be accessible from the outside. So we have to allow traffic to EC2. And this is done, there is this concept of security groups in AWS, and these allow us to specify all sorts of rules about how our servers are accessed, how our resources are accessed. So for sake of simplicity, I'm going to change the default security group. There's best practices around these particular, security groups. I'm definitely not an expert on this. So if anybody wants to throw a book at me, a security book at me, please do. So I clicked on that link. I went to the default security group, and I'm going to edit the inbound rules. See down here. And I need to allow HTTP 80, that's what we enabled on our container, over any IP in IPv4 and IPv6 IP. So we're just opening it up to the world. Whoever wants to get to it can. So finally, there's also in order to get a DNS name for our server, which right now, if we were to look at our EC2 server, we would see that we don't actually have a DNS name available. It's just simply we can't access it. So we go back to I skipped a step here, so I'm going to go back. We have the concept of virtual private clouds, and these are ways to encompass portions of our network. We can have one big virtual private cloud. We can segment them into multiple different private clouds. You would do this for security purposes. If you want to make a DMZ, that sort of, you put your vulnerable servers out there, and you have your more secure servers in a more confined VPC. Just allows you to avoid people hopping from server to server, exploiting a vulnerability on one server and getting access to your very sensitive Postgres server, for instance. So if I click on this VPC ID, I get to this screen, and I need to select edit DNS host names. And this allows me to say, yes, when I create a server, I want it to have DNS host names. I want it to have a DNS host name. I want to be able to type ec2-1234 dot some ridiculously long DNS name.com. So I do that, and I save that, and now I can connect to my EC2 instance. And we do that, if we go back, we use SSH, and there's a whole lot of commands here that we have to do. I sort of group these together. It's also available on the GitHub repo, but we have to install some things via Yum, some of the Amazon extras. We have to install Docker itself and essentially get everything set up. This is sort of the general Docker setup that gets us ready to host our application. And then we want to actually create our Docker container. So we have to have a place for it. So we make in the var directory, we can create a www directory, and we make our little folder for our Rails app, and change the ownership to our EC2 user. This EC2 user, when you create a EC2 instance using the Amazon AMIs, when you log into a system, SSH, you are under the EC2 user. It's not usually very clear, so it's very helpful to know that when trying to figure out, who do I give access to what. So finally, we clone the Git repo, we change directory into the Rails app, and we go back to our Docker compose commands, and we simply build, start up our compose containers, and we run our create and DB migrate. And that's it. Now we are able to run this locally and on the server. If we get new changes to our Rails application, we can simply pull from GitHub and rebuild the server, and it will just recreate whatever it needs to recreate, and not touch any of the images that need to be updated. I assembled some very helpful commands. One thing I was having an issue when going through Docker was, how do I delete all these containers that build up? Because I was getting a lot of orphan containers. Docker has a remove function, and we are essentially passing in another command to say, like, get rid of all the dangling containers. We talked about showing running containers. We can delete all containers if we want. There should be a comma or a parenthesis at the end of this. And maybe we want to access the Rails console. And it's the same thing as when we run DB migrate. We simply say we want to run on the app the command Rails console, and we get access. So I think And how am I doing on time, Ryan?
Yeah, you're good. I think
Okay.
it's real interesting. Keep going.
Okay. So when you install Docker, that's not how you spell Docker at all. You get this nice little uh, um, widget application they get to run, and it gives you this very pleasant looking dashboard, which we can see there's no containers running right now, but it's very helpful. So if we actually go into our so I've cloned the repository. Oh, there's one. Let me delete that. So I'm going to go through and make sure that I am cleaned out. So I'm going to grab this dangling commands, and I'm actually going to run it to try to see if I can get rid of any of the the containers that I currently have. So you can see there, it's going deleting everything that I had. Nothing's really important. This is since it's Docker, we can constantly recreate our containers very simple, very quickly. Okay. It's taking a very long time. You can see I have a lot of failed attempts to create my containers. Wow, that is a lot. Okay, great. So if we go back, and I'll put this side by side, if we go back to our commands here, how do we build? Well, if we look at my directory here, I have my Docker folder. We can see I'm already all set up here. I have Docker app, I have my app Docker file, my web Docker file, my compose file. So all I need to do is Docker compose build. And this is the part where we talked about, see, we're now using, DB is using an image, so we don't actually have to go and get the Docker config file. We simply download that image, which, since I've already done this before, it's already downloaded. And we start building the app. And this might take a very long time. So while we're doing this, I'm going to jump over and we're going to start launching. We're going to, oh, there we go, of course. We're going to launch an EC2 instance. So this is the screen that we saw before. We're on the EC2. So if you want to find it, you simply under here, compute, or you search EC2, and we can see EC2 and click on it. And we load the screen. And we have 0 running instances, so I want to click on that and I want to actually launch an instance. So we launch. And so again, I'm going to pick a Amazon Linux AMI. I'm going to pick the latest one, the Linux AMI 2. I am going to pick a micro instance so I don't get charged, but there's a lot of, I mean, we can get 32 gigs of RAM, 8 CPUs. There's different types of instances we can get. GPU instances, FPGA instances, it's quite extensive. So we review, and we see here is our server. We don't have to really change anything. We might, it might be worth it. Maybe we'll change the security group, and no, I won't do that. Because, okay, so I'm going to go ahead and launch it. And I already have my existing pair. I created Rails server key. So I'm going to acknowledge that I have this, which I do. And I'm going to launch it. And if we look over here and I look in my folder, in my Rails talk or AWS Docker talk, I have my Rails server PEM key right here. So once this instance is available, which this may take some time, and we will be able to SSH into it. So this is still going. I can kind of describe a little bit about what's going on here. If you look, we can actually see here is our commands that we specified in our file. We are creating an image from Ruby 2.7. We are running these commands. And if you get an error here, it will just simply dump out and give you the error. We come down here and it's going through, and now it's building. So it successfully built our web server. And now it's building our web, the web portion of it. Okay, so I'm at a bit of a standstill. Is there any questions that I can answer? Like I said, I know it's a lot to kind of go through at once. Any questions from anybody?
Can you provide more context on the cost benefit analysis? Like, what was the rough numbers you were seeing that prompted you to make this change, and like what kind of savings did you see?
So we were just running a Heroku instance that was allowing us to even like test and serve initial customers. You know, one instance was $300 to $400 per month, and that was just, you know, then we were looking at the projected cost of, well, we couldn't actively predict what customers were going to use the system in what way, because we're very early startup. We've been around a year. So the answer was to go for higher end, dynos. So really we were going to need the professional dynos, which was, you know, could be up to $250 to $500 per month. And realistically, for some of our customers, they were using gigantic amounts of data, long running processes. So we would essentially, to onboard a customer would cost us, you know, $200 to $500 a month, which was just, it was unrealistic for us. So going to EC2, in the instance that we configured, I was able to get a significant more amount of memory processing, and even the ability to spin up a whole new server and change our distribution, was under just $100 or less for the instance that would allow us to support our first batch of customers, versus we were looking at thousands of dollars to tens of thousands of dollars a month.
I did not realize the markup was that high for Heroku. Is that what everyone else has seen?
It's not, I'm sorry to answer for everybody else, but it's not generally, for the most part. I have worked at places that we got away just fine with Heroku, you know, instances, or databases weren't very large. And this is where sometimes, a lot of times, you can sort of see the incremental cost is that, well, you need more from your database. Suddenly it's a few $100s for your database. Your Redis instance, a few $100s for your Redis instance per instance of Heroku. So in our specific case, Heroku just didn't fit what we needed for our platform, which is we take in large amounts of data from different data sources. We compute it through our engine and spit it out to be available via different products. And it was just, we couldn't foreseeably see a way to do that with our limited resources and engineering department without.
Do you employ DevOps engineers then?
No, not currently.
So who holds the pager on these instances then?
Well, sorry, that's not true. It's not employed, but we have a part-time DevOps person that helps me with AWS and Heroku. But currently it's the pager is, you know, since we're early, it's me, it's my other co-founder, and we have an additional person in Colombia that would also handle some of the pages for us.
Cool, because that's been the general equation when I've seen startups go through this phase of trying to make this decision is the cost of ops versus the cost of
Exactly.
Heroku. Yeah.
For us getting started, there was no question Heroku was the answer. It's like it allowed me to not have to really worry about all sorts of configuration and management. I could hook into our continuous build, and we had automatic deployments, and it's fantastic. But to be honest, we're still running some of our lighter weight servers, our web servers, because our main engine is sort of it handles the bulk of the load for sort of facades for web apps that we have that host our shop, host our microsites, host our APIs. So it was really this process of running these large computations. It just wasn't scaling properly for us in Heroku. Cool. So to kind of continue, we finished running here on my local environment. So I am going to Docker compose up D to start, and we can see we're creating our containers. And if we look over here, you get this nice little view of our DB app and web. If I go to localhost 3000, I see our web app is running. We can create a post, body, publish, create post. We go back here. Great, we have post created. We can see our logs if we want, stats on how everything is running, database logs. Of course, we could also see these things using Docker compose PS. We see our servers running. We can also Docker compose logs, and let's see. I actually have to get the container ID. So we'll get this container ID right here. And let me make this bigger so it's easy to see. Docker logs. Oh, that's the wrong container. Sorry about that. There we go. So we can see the logs. There's options to actually follow the logs and tail them. So we have a working local instance, but what about EC2? So I'm going to go back to our EC2 instance over here, and I'm going to click, so I have it selected. Oh, and just to kind of go through, I forgot that I have to actions and networking. We're going to change the security group, and I'm going to add default back because I've already configured default to have the correct inbound configuration. And if we look at our VPC instance, we can just verify that we have some of the other aspects configured. So DNS host names, it's enabled. So if we come over here to our EC2 instance, we can see we actually have this public DNS that we can access, which if we go to now, we get nothing. There's nothing actively running on our server. So I'm going to go ahead and connect. I've already done this chmod. So I'm going to simply SSH into my box. And if I look locally, I see I have my Rails PEM file here. And of course, I copied that. So SSH, do you want to connect, accept the fingerprint? Yes. Permanently adding. So now we are in our instance of EC2. So I'm going to go back here and I'm going to run through these. So we have to sudo yum update y. This is just simply going to go through and make sure that we're up to date. We have all the latest list of packages for our system, and I need to install Git so I can actually download. Yes, can clone our instance. So that completed. Then I'm going to grab this command so we don't have to type it out. We're going to install Docker. Yes. Okay, that completed correctly. We're going to start Docker. We're going to change user mode to allow us to run Docker commands using EC2 user. Now, you either have to log out or rehash the command. I'm going to log out for now to essentially make this change so I can run all the Docker commands. And we are going to now get Docker Compose because it's a separate element of our, it's separate from Docker. And I'm going to change it so we can actually run the Docker Compose command. And I'm going to execute Docker Compose to see the version. Great, we have success. So next, we are going to change directories into our var directory, which has a bunch of different things, but doesn't have our www directory. So I'm going to make that, and I'm going to change, which I will add that in here. I did not say to change into the www directory, but I'm going to make a directory to house our Rails app. cd www. Need the right amount of W's. Make our Rails app directory. We're going to change the ownership to EC2 user because if I don't, I have to run a whole bunch of commands using sudo, and this is generally not a good idea for security reasons. And I'm going to now clone the application, and I'm going to change directory into our Rails app. So now we are in a Rails app that we have seen before over here with all of our files. So now, in theory, I should be able to go just like I did locally, Docker Compose, build, run through this. Hopefully this doesn't take as long because I'm not being bogged down by Zoom. So this is what we didn't get to see before. We're downloading our image for Ruby. We're pulling it from the Docker Hub, which I put a link in all the way back. I don't think I put a link to it. Okay, I will put a link in the chat afterwards, but like I said, you can explore and there's all sorts of different packages out there for anything you can think of. Okay, and so it's almost done. So now we're going through, this is probably pretty familiar, we are now doing our bundle install, installing all of our Ruby gems. Come on. Installing Selenium WebDriver. Any questions while this is running?
Yeah, actually I had two main ones for you.
Okay.
So thanks for the presentation. I used to use Docker years ago and kind of gravitated away towards it. So it's good to see some updated stuff. But for production setting, how do you scale this process out? So do you use anything like AWS Elastic Container Service or their Kubernetes service? And then secondly,
the answer to that is no. I am. This is my beginning to Docker because And that was going to be the end. I was going to say there's all sorts of next steps to this because, yeah, that is sort of my next exploration is how do I scale this to make it as effective as using essentially Heroku with my deployments. I can assume that you can use
those services either, but
yeah, and I mean there's stuff like Ansible or you can write. I'm sure you could write all sorts of like different there's different deployment platform. I mean there's even the old Rails one that starts with a C. I can't remember, but
yeah,
anyways.
There's one called Cloud. There's AWS CloudFormation, which is basically an Ansible for AWS stuff.
Yeah, and that we did use that on our initial AWS setup. We use AWS for a lot of stuff: DynamoDB, Postgres, MySQL, Redshift. We use it for all sorts of stuff. And our initial setup was using the CloudFormation, which is pretty extensible and very nice.
Right.
I guess you. Oh, go ahead. Sorry.
Second question would just be about databases. So, like, we're pretty protective of our Postgres database, and we have an RDS instance with backups and all that kind of stuff. How do you run production Postgres databases in Docker?
No. This is again an example, but I made it like sorry, words in my mouth. RDS, Redis and Postgres are actually running on RDS and Elastic Cache. And we simply, if that's the case, you simply don't include, so like locally, for our Docker Compose file, I have two different Docker Compose files. I have so if I duplicate this, we actually have a Docker Compose dev file, which will have Postgres running in a container versus the main Docker Compose file will not have the database running. And we set use typical environment or configuration files to actually say, here is the database you should connect to.
Okay. All right.
So this is just an example. I also, you can, like I said, you could choose to do it this way. Like you said, I have RDS, Redis. It's just makes sense because you can scale those particular environments separately of your application server.
Mm-hmm. Yeah. And I always treat application servers as compute units that could go away.
Exactly. And that's a nice thing I've been finding about Docker is that it's very easy for me to go, oh, I screwed up, start over and just rebuild very quickly. I mean, of course it's not going so quickly here, but overall it's a pretty painless process once you can kind of understand the sort of language of Docker.
If I could ask a question, kind of rolling back, just a quick, I was trying to get an understanding. So you said it was 2 people on your team that are managing this. How big is your engineering team?
We have about 8 or 9. Well, engineering team's about 3 or 4 people, and total on the company is about 8 or 9 people.
And okay. I'm trying to understand it because you guys made did you run out of scale? It was a scaling issue that you left Heroku for AWS, or was it more of a personal choice?
It was scaling and it was cost, because we looked at our funding and we said, well, we could run out of funding very quickly, scaling for these customers that aren't paying us enough to support them, or we can move to AWS EC2 for, a fraction of the cost and be able to, as we go along, we have a lot of work to do in order to change our architecture to allow for more sort of decoupling of our data pulling and our computation. But, as startup life is, it's like we chose to do very specific things to get a product done. So cost and just general
I guess that's a piece. I don't mean to ask a tough question. That's the piece I'm struggling with because I've worked in a number of startups. I'm trying to see. I've never seen the cost. Usually I see it the inverse, like exactly the opposite of what you're saying. That's why I'm missing something. So I'm asking a tougher question, just trying to figure out if you need some specific use case like Lambdas or something that you can't get, but I'm just wondering where that marker might be, because usually it's the exact opposite. Because Heroku, even if you're 200 or 300 grand a month, that's still less than 2 DevOps people.
Yeah, that I'm with Chris. I think that's the magic number I've seen generally, is if you aren't spending if you're spending under 100K a month on Heroku, I've never seen someone make an argument for that, which is why this is like a little tricky to understand.
Yeah, and that's the thing. It's like for us, it's literally a funding aspect. It's like we are angel round going into our seed round, and we built a platform that wasn't very well suited for Heroku for us. And I guess we are lucky in that we have I have a lot of expertise doing IT infrastructure stuff in the past. I was able to hire somebody part-time to handle a lot of the sort of extraneous work. But yeah, you're right in the case that if we were to pay specifically a DevOps person, it would make sense. But right now it's sort of scrappy startup trying to make do and not having to go out of business because our customers are running our resources into a ground.
And I think it's just he's getting at is there's custom things that they need for their business that require this sort of solution.
Yeah.
And maybe you're not able to share it. That's why I'm just wondering what that custom piece is that was that's like we use Docker and Kubernetes where I work, and I understand those principles of it, but I was just more intrigued by the customization. Like, what was it?
Well,
like, is it just the number of dynos or like the number of workers?
Yeah,
it's
and this is
right. You have a set of environments for every customer, right?
No, not a separate environment. And that's sort of, we built a platform this Algoly magic that I talked about before, it allows us to take any data source and pull it in, however big the size, however big the complexity, and create a sort of DSL for that we can then Lego piece together to create, or the customer can, in order to create solutions. And that portion, the pulling of that data, the managing of, if it's an API and how do I throttle that? And then I get this data here and I'm running complex, quote unquote, algorithms against the data. It's like at our stage, we weren't able to have the funding to have enough time to build a platform that we could do this in a super efficient way, while also having it be in a very predictable way. So we sort of had this issue where we were throwing resources at it, and those resources were going to quickly scale out of our existing, funding that we had in our runway. So anyways, like you said.
Thank you for that. Thank you. I didn't mean to poke. Thank you.
No, it's okay. No, it's, like you said, it was an active decision. I went, I could keep going down the Heroku route and I could have, just pay the money, but, for our funding and for what we were trying to build, it's just like, it didn't make sense. And we needed to cut over, we needed to do it now before we sort of got too far down the line. We were too far in the weeds of Heroku. So anyways, it built, so now we can start our our AWS instance. So there it goes, pulling the DB image, and it started it. And finally, we need to do our migration or create our database. Yeah, I thought about going into detail about how splitting these out, and I realized there's only so much time in the day. And I did not set the secret base. Hold on a second. Forgot a step. So. We have gone to, we're in a stalemate here. So app, I think I have to set this now in yeah, I forgot to set this here. So there is a the rake secret. And then I need to sorry, let me go grab the here. I need set secret base equal. Why isn't it responding? Equal to this key. Let's try it again. So you can see it's going ahead, it's recreating my instance with those environment variables. It didn't actually like dump any of the file system. It just made the necessary changes and created the database and migrate. And then if we go to our instance over here, and we grab our DNS file. Let's hope this works. And we got a bad gateway. Okay, well, at this point, I know I'm running out of time, but I'm sure there's some sort of issue with my Nginx configuration that might have changed, but at this point we should have gotten the Rails application and it should work correctly, but not to kind of go over time, you know, we kind of get the point of what we're doing here. I'll just open this up to other questions if anybody has any other questions.
I'm curious about why not Kubernetes?
Because I don't know Kubernetes, and I don't know Kubernetes, and Docker seemed like the sort of the next logical step for me from my virtual server IT background that dates back to Windows NT, you know. And
okay, so Kubernetes is just a platform to run Docker containers.
Yep.
And like watching you go through and set up raw Amazon instances just makes me like that, again, that balance between ops time and cost. Okay, so you're not familiar with Kubernetes, so you investigated Kubernetes and been like, here are the 7 reasons why we didn't choose K8s.
No, it was simply like you said, Kubernetes runs Docker containers, and I was like, well, I need to know how to use Docker first. That would be a good first step. So that's obviously like a next sort of exploration is where do we go from here? And that sounds like a really great talk is how do you take what I did here and make it work for Kubernetes? I nominate you.
I would suggest you look it up. It's super easy. Once you got the Docker files, you eliminate all the Docker Compose stuff. It actually might be a better solution going forward for you than continuing down this path.
Sure. All right. We'll take a look at it, but yeah, that's sort of next step. Other questions?
I just had a statement that I think this is like a really, really well done presentation as far as all the details and screenshots and all of that. Just sort of walking through all these steps, even though the final thing is probably one little setting, but that's no big deal.
Yeah.
So like live coding, live, generating and all of that. It takes a lot of prep. And
I will say, I worked at a company, we hired an AWS consultant and they couldn't do in a week what you just did in an hour.
Yeah.
Which I don't know what that says more about you, AWS, or the consultant.
Probably the consultant, but I mean, the thing is that AWS, like I said, it's a very complex beast. I mean, if you look at services, it's for a lot of people, it's like, where do you even get started? And for me, it's like, I only know as much as I know, and this kind of goes to Kubernetes talk. It's like I knew virtualization, Docker containers seemed like the next step. So that's why this sort of decision was made to go with Docker, because I actually set up initially our servers on EC2 and I went, wow, this is a lot of work. This is not going to do it. This is going to be, the server's going to fail, and for some reason it's going to disappear, and I'm going to not remember how to set it up again, which, is not worth it.
I have a question related to your stuff. Are you using the default cloud-based logging products from AWS, or do you extract that to something else?
I say that again. The default cloud front what?
So one of the things that we encountered in a couple of different installations is the AWS logging. What is it called? Not CloudFront. What do they call it?
CloudWatch.
CloudWatch is absolutely atrocious. And I was wondering, is if you've used another product or you are using CloudWatch based to do anything in the logging parts of your app.
I'm actually using Sumo Logic at this point.
So you extracted it. Okay.
Yeah, we drainage from multiple sources, and
yeah.
I mean it's a little bit hard to get started with because it's like you have to create these queries and whatnot, and my developers were a little bit confused at first, but so far it's been doing what we need.
Cool, thanks.
No worries. Any other questions?
Kind of just a very generic one about the hosting or servers in general. Like, I've only used Heroku and DigitalOcean at this point.
Mm-hmm.
Are EC2 instances, does anyone know, just on a top level, similar to like a DigitalOcean style pricing in terms of resources, or are these even insanely cheaper?
From what I remember, DigitalOcean was, I mean, you could have fairly cheap, but the fact that from what I can tell, AWS's instances are pretty cheap too. Sometimes you can get away with them being free if you run the free tier, and that's good enough. But
you can buy reserved instances where you pay up front and it's super, super cheap.
That is true too.
You can save like over 50% doing it that way.
It varies. Well, we're grossly simplifying it. It varies a lot by your configurations. It also varies on the size of the processors and everything else that you're using.
Yeah.
Amazon's pricing just recently changed. It used to bill for an hour. So if you use the biggest node, you get billed for an hour for 1 minute of processing. They modified a lot of that. So if you're ever deciding to switch, that all has to be played in, because the nodes, depending on how many you need and the sizes per hour, can be quite fun to calculate what your budget estimates are.
I'm pretty sure there's a Boulder startup that literally all they do is help you manage the configuration of AWS spend because of those problems.
Yeah, probably.
That's why I was asking. Yeah, because I know a guy that does one for the like Ruby and Rails apps towards. It's really easy to set up on DigitalOcean. So I was seeing the time spent versus, what the cost and resources are that are available.
Yeah, and like we were talking about before, there are other ways, not just EC2, that you can, distribute that cost. Lambda is one of them. I know we had a talk about, using Ruby on Lambda. This is obviously not my company's AWS instance, but we have a whole bunch of different functions that we use for handling gateway requests, to doing processing, to doing importing, where it's not really necessary to host an entire server for that. As well as like obviously running, if you want to run a database server, there's RDS, and there's ups and benefits and pros and cons to all of these things. And obviously it takes time to learn how to manage them, which is why generally you hire a DevOps person.
Yeah, I think that the cost generally, if you don't need the complexity and sort of the expanse of AWS or GCP or whatever, that if you just need a simple server, that DigitalOcean will still be more cost effective.
Yeah, mostly.
Definitely depends on how you use it. Sure.
Any other questions? Okay, well, like I had mentioned, the GitHub repo is up here. It's in the slides. I cover the commands you have to run. Everything that you saw here is available to play around with. If you just simply even just walking through, if you want to start on your own, you can walk through these slides. Overall, it's going through is pretty interesting and cool to see like how things have changed in IT over the last 20 years. Like Kubernetes, like Docker, like everything. There's just so many things that are available, and makes setting up servers just so much easier. So I'm going to go ahead and stop sharing my screen now. Thank you.
Thank you, Carleton.
Yeah, thanks a lot.
Yeah, appreciate the time and effort.
Thank you so much,
man.
man. Thanks.
It looks real dark. I'm going to go stop my video and turn on the light.
Yeah, you went from evening to 2 a.m. pretty quick.
Yep. Okay, that actually lands right on the kind of time of end of the meeting. I don't know if it'll kick us out or whatnot, but
It won't. Do you want it to? I can kick y'all out. I have the power.
Joel has the power.
On that note, I'm going to stop the recording.
this
Don't
seems
let that
better.
go to your head, Joel.
But yeah, thanks, Joel,